Here we go, guys. We have a video on the practice quiz 8.1, 8.2. Let's jump right in. So this first question, it says, what is the range of the above exponential graph? So we have an exponential graph here. We need to recognize that from left to right, it is growing away from the asymptote. You see the asymptote right here, that's the vertical line y equals 2, okay? And from left to right, it's growing away from that asymptote, that horizontal line y equals 2. Did I say vertical? Horizontal line y equals 2. So it's growing away, so that means it's a growth function, okay? What is the range of this exponential growth function? Well, range are your y values. Keep that in mind, right? The range are your y values. So obviously your x's are running left to right, your y's are running up and down. So the question is, does this go up forever? Absolutely. You see there's an arrow, or it's kind of cut off, but it does go up forever. But it does not go down forever. It goes down, 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 and then it infinitely approaches that asymptote y equals 2, but it never actually touches it. In other words, could y be 0? In other words, does this graph ever touch the y value of 0? The answer is no. Does it touch the y value of 1? The answer is no. Technically, it doesn't even touch the y value of 2, but we do know that it's infinitely close to it, and we know that it's above the y value of 2, so the range are your y values that are greater than the asymptote 2. Now, if you put or equal to, that would be incorrect, because or equal to implies that it actually touches. Now, when we graph it by hand, we do draw it like if it's touching, but we know that it doesn't actually touch it, it just infinitely approaches. So y is greater than 2. And it's important to note that the range will always be y is greater than whatever your k value is, or y is less than whatever your k value is. And again, the k value is what the asymptote value will be, okay? Y equals whatever that k value is. So there's our answer. Y is greater than 2. Right here we have an exponential function, and if you think about it, from left to right, what is happening? It is decaying infinitely towards the asymptote value of y equals 1. Again, the asymptote line is the horizontal line, y equals whatever it infinitely approaches, which in this case is y equals 0. So it says, which of these following equations represents this exponential decay function? Well, first of all, if it's an exponential decay function, we know that our b value, and what am I talking about, the b value? We have y equals, we have the a, I'm going to put the parentheses b to the x minus h plus k. This is the form that we want. And we should know from all the other graphing we've ever done, a, if it's negative, it causes a reflection over the x-axis. It also tells you if it's a vertical stretch or vertical compression, based on if the a value is greater than 1 or between 0 and 1, right? And the b value is what determines if it's a growth or decay function. This is called the growth or the decay factor. Okay, now if it's a decay function from left to right, it's decaying towards the asymptote value of y equals 0. Then this must be a value that's less than 1, a fraction or decimal that's between 0 and 1. So obviously this is 3, which would cause it to grow. So this one's definitely not it. And if you look at the answer, it's obviously not it. This other one, 2, that's definitely not it, because that would be a growth function. So it might be this one, 1/2, it might be 1/3, or it may be none of these are correct, okay? So how could we determine whether it's 1/2 or 1/3? They're both decay functions. How do we know? Do we just guess? Absolutely not. What we want to do, whenever you're faced with a choice of like which equation is it, you could always pick a coordinate, and I'm talking about a nice coordinate. Like let's say this coordinate right here. That coordinate is -1, 3. Okay, so -1, 3. What is a coordinate after all? It's an input of x into the function that you have, and you do the math and you get the output of 3. So the question is, which one of these will give us the correct output of 3 when I input negative x? So when I input negative x right here, which is -1, I'm sorry, not negative x. When I input x of -1 right there, it's going to be 1/2 to the -1 power. We should know that the -1 flips it and that becomes 2 over 1. And 2 take away 2 is 0. So for this function, the input -1 gives us the output 0, which is obviously not -1, 3. So this is incorrect as well. And this other one is the correct answer, as you can see, because when we input -1 right there, -1, 1/3 of the -1 power. -1 power means that you flip the fraction, so that becomes 3 over 1, which is just 3 to the 1 power. It's still just 3. So when you input -1, it does give you an output of 3. That's how we know that this is the correct answer. So yes, you could look at the B values to determine which one's the growth, which one's a decay. But if you have 2 decays, and you know this is a decay, and you have 2 decays, and you actually have to look at the graph itself, pick a nice point, and test that value. Plug in the input, -1, into X, and see if you get that output 3. That will tell you which one it is, which in this case is this one. Let's move on. We have a true or false statement here, or actually select all the true statements. So let's read through these. When graphing an exponential growth function, or technically a decay, doesn't matter, by hand, you should use consecutive integer inputs like -3, -2, -1, 0, 1, 2, 3. That is absolutely true. Okay, well, I just showed you all the answers. I apologize there. It's true. Why is that? If you take any y equals, let's say, 2 to the x minus 1, or whatever, let's just stick with something basic like y equals 2 to the x, and you do consecutive integer inputs on an xy table like -3, -2, -1, 0, 1, 2. Start out with the easiest one, which in this case is 0, and you input it. 0 goes into the x. 2 to the 0 is 1. So when you plug in 0, you get out a 1. That is an actual coordinate. And then from there, if they are in consecutive integer input order, right, -3, -2, -1, 0, 1, 2, you're not skipping any numbers. They're in perfect numeric order. Then you could use your growth factor of 2 to get from one output to the next output. So this 1 times 2 will get you 2. And then 2 times the growth factor of 2 will get you 4. And you get all the coordinates that you need. And even backwards, if you're going times 2 this way, backwards would be dividing by 2. So 1 divided by 2 is 1/2, divided by 2 is 1/4, 1/8, and so on and so on. So that's why it's so excellent to use these consecutive integer inputs if you're graphing by hand. Of course, if you have a Desmos, then that's a lot better and faster. Let's move on to the next one. It says the asymptote is the line x equals h. That is false. Anytime you graph an exponential growth function, the asymptote will be the k value, okay? And it's not, the x equals h is a vertical line, which is incorrect. We're talking about y equals k. So in order for this to work, it should be y equals k in order for it to be true. Obviously, this is not the case. That's why it's false, okay? None of these are correct. Obviously, that's not true because we already know that that first one was correct. The asymptote is a line that your graph will infinitely approach but never actually touch. That sounds absolutely right. That's why it's green. What else? The range of an exponential growth or decay function is y equals all real numbers. We know that's false, right? When you have an exponential growth function, it grows, and the range is up and down, and it doesn't go up and down forever. It goes from the asymptote value, in this case of 0 and above, so it would be y is greater than the k value 0. Obviously, there is no plus a number over here, so it would be plus 0. That's why the asymptote value is 0. So the range of any exponential growth or decay function is y equals all real numbers. That is false. What could be said to make this true? The range of any exponential growth or decay function is y is either above the k value or below the k value, right? That would make it a true statement. Anywho, those are your answers. Let's move on. Which of the following are exponential decay functions? That's pretty simple. From left to right, the way you read sentences, from left to right. If it infinitely approaches your asymptote, that's a decay function. From left to right, if it infinitely grows away from your asymptote, that's a growth function. So first, I'm going to, they're already drawn here, the asymptotes, right? The asymptotes. Asymptote is up here. So from left to right, this guy grows away from that asymptote. That's a growth function, and we are looking for decay functions. So this one's definitely not it. This one right here, from left to right, it grows towards the asymptote. not away. It doesn't, actually, I shouldn't have said grows towards. It decays towards the asymptote, right? It decays towards the asymptote. What do I mean by decays towards the asymptote? Well, there's a pretty big gap right here. And as you go from left to right, the gap decays, it gets smaller. The gap decays, it gets smaller and smaller and smaller until it looks like it's touching, but we know it doesn't actually touch. It just infinitely approaches. So this is what we call a decay function, right? It decays. So, and not only that, if you're thinking, this is not a decay function, it looks like it's growing up, it's growing towards, that's false, right? Because an example, a real world example of this would be like, let's say you were in credit card debt and you started paying it off. You got a lot of debt, you're way down here in the negative. Pay it off, pay it off, pay it off until it's completely paid off. That's a decay function, right? You're decaying your debt. Anyway, this from left to right, it decays towards your asymptote, which means that this is a decay function. That's why it's green. The other one was red, obviously. Is this a decay function? The answer is yes. It decays towards the asymptote from left to right. You're not going from right to left. That's incorrect. The way you read sentences from left to right, it's getting closer and closer and closer. It decays towards the asymptote. So that is also a decay function. And this one's even a decay function. Okay, it's decaying towards that asymptote, then infinitely approaches it, never actually touches it. So that's also a decay function. So the only one that wasn't was this guy. That was a growth. Let's move on. Which of the following are exponential growth functions? Okay, so when it's a growth function from left to right, the way you read sentences, right? Which of the following? You're reading it from left to right. When you look at these graphs from left to right, if it grows away from the asymptote, then it is a growth function. So as you can see right here, it's growing away from that asymptote. So it's growing away, so that's a growth function. This one from left to right, it's growing away from the asymptote y equals 0, so that's a growth function. This one right here, it's on the asymptote, it's growing away from the asymptote, so that's a growth function. Wow, all of these are growth functions. Right here, it's growing away from the asymptote y equals -1, from the k value -1, so that is also a growth function. All of these are growth functions. Trick question, I guess. Let's move on. So it's one thing to visually see the graph from left to right. If it grows away from the asymptote, then that's a growth function. If it decays towards the asymptote, it's a decay function. That's pretty easy to do from left to right. But numerically, you got to look at your b value. If you're not looking at the graph, you got to look at your b value. If the b value is greater than 1, then it's a growth function. If your b value is between 0 and 1, then it's a decay function. Okay? So 0.99, that's a decay function. That makes total sense because if you take any number, like if you take the number 20 and multiply it by 0.99, the answer will be smaller than 20. It decays, right? If you take any value and multiply it by a number that's greater than 1, it's going to grow. So the b, if it's less than 1 or between 0 and 1, that's a decay function. If it's greater than 1, it's a growth function. So this one's definitely a decay function. They're asking for decay functions, so this one's decay. That's why it's green. This is not a decay function. 2 is going to cause anything to grow. 2 times 20, it's going to grow to 40, right? It's not going to decay, so this is a growth function. Don't pick that one. That's incorrect. It's obviously not none of these. What else? Over here, this is a decay function. Decay function. Why? Because the base is between 0 and 1, 1/2, right? The value of 1/2, it doesn't matter if it's a fraction or decimal. If it's between 0 and 1, it's going to cause it to decay. 20 times half is 10. It gets smaller. 20 becomes 10 if you multiply 20 by 1/2. So the 1/2 is going to cause a decay. This is a decay function. That's why it's green right there. Last but not least, if you're thinking, oh, it's a fraction, it's a decay function. Wrong. Why? Because what is 3 divided by 2? $3 divided by 2 is $1.50. That's greater than 1. 1.5 is greater than 1. That's going to cause it to grow. If you take 20 and multiply it by 3/2, if you take 20 and multiply it by 1.5, it's going to grow to 30. So this is actually a growth function. Again, for growth functions, this is not a decay function, that's why it's red. For growth functions, it has to be a value greater than 1, a fraction, decimal, number greater than 1, that'll cause it to grow. For a decay function, it has to be a decimal or fraction that's between 0 and 1. That's a decay, that's a decay. Moving on. So on this question, we have to select all the exponential growth functions. And again, if your base is greater than 1, then it's going to cause it to grow. It'll be a growth function. So 9/10, it's not greater than 1. So that's not a growth function. Right here we have 1.001. That's definitely greater than 1, so this will be a growth function. That's why it's selected in green right there. Over here we have the base 1/2. That's a decay function, not a growth function. It's not greater than 1. So it's this last one, 5/2, that's really 2.5. 2.5 is greater than 1, which means that this is a growth function. So out of these, only these two are growth functions. Let's move on to number 8. Right here we have a growth function because the base is greater than 1. There is no h shift, there is no k shift. The a value is 1/2, which causes a vertical compression of this growth function. Anyway, this is a decay function. False. That's a growth function, so don't pick that one. The asymptote of this equation is y equals 0. Remember that the asymptote of any growth or decay function is y equals the k value. Okay. Now, obviously, there is no h up here with x, and there is no plus k, so it's technically plus 0, which makes sense that the asymptote is y equals 0, the horizontal line y equals 0, which is really the x-axis in this case. So that is a true statement there. What else? It says this has a y-intercept of 2. Well, in Algebra 1, we learned to find the y-intercept, you set x equal to 0 and solve. So if you put a 0 up here, okay, that'll be 2 to the 0, which is 1. And then 1 times 1/2, that would be 1/2. So the y-intercept, when you plug in 0 for x, you get a 1/2 out for a y. So this is definitely not the y-intercept of 2. It has the y-intercept of 1/2. So this is false. That's why it's red. On this last one, it says from left to right, this graph will grow away from the asymptote. And this is a growth function, and it's true that growth functions from left to right will grow away from the asymptote. So this is a correct answer. Another true, select all true statements question. Right, here we go. It says all exponential decay functions from left to right infinitely approach but never touch the asymptote. So what is a exponential decay function? I want to do a quick sketch. From left to right, it's going to decay towards the asymptote. Okay, and then it infinitely approaches but never actually touches. So here's an example of an exponential decay function. This one is probably, I don't know, let's call it y equals 1/2 to the x. But anyway, is this true? All exponential decay functions from left to right infinitely approach but never touch the asymptote, in this case y equals 0. That is true. Okay. Next one, the range of this exponential growth function, I say growth because the base is greater than 1, it's 2, which means that from left to right it's going to increase, it's going to grow. It's going to grow away from the asymptote. It says the range of this function is y is greater than 3. This is false because we need to remember that you have your a value out in front, which causes a reflection or a vertical stretch or compression. You have the b value, which tells you whether it's a growth or a decay. So this is a growth. And then you have your h value up here being subtracted from x, so there is no shift left or right. And you have the k value, the constant at the very end, the -3, that tells you that there's a shift of 3 down. Okay, so this is a growth function. Let me just do a quick sketch so you can know what I'm talking about. The original growth function goes like this, and it originally has the asymptote on the x-axis, but because of this -3, it gets shifted 1, 2, 3 down. So your new graph is going to go off of this asymptote at y equals -3. So here's your new graph. Okay, it's just a sketch. So this is saying that the range, the y values of this red line are at y is greater than 3. That is true because this red graph exists up here. It has a bunch of y value. It does have the y value of 2, the y value of -2, -1, 0, all the way up to infinity on y. But the graph never goes below 3, -3. Actually, it never even touches -3. It gets infinitely close to -3, but never actually touches -3. So where's this graph at in terms of up and down, in terms of y? You're going to say this graph is at y is greater than -3. So this is false because it says y is greater than +3, but it should have been y is greater than -3. So this makes it false, and that's why this is not a true statement. It's red. Why do I have 2? None of these are correct. Okay, I'm gonna have to fix that. I apologize. So obviously we know that none of these is not the correct answer. Let's go over here. If b is any fraction in this form, okay, so if b is any fraction, then it must be an exponential, I believe that says decay function. Let me move it over. That is false. How do I know? Because I just saw the answers. No. The fraction, if it's greater than 1, it's going to be a growth, right? So it's not just that it's a fraction, right? If b is any fraction, what if it's 3 over 2? That would be a 1.5, which would be a growth function. So that's why it's false. So I am going to change, I'm going to change this on the actual test. Let's do this. I want to change this, none of these are correct, to this statement. Y equals negative base 2 x minus 1 plus 9 will never touch quadrant 3. That will be a true statement. Okay, let me do a sketch of that for you. We know, I mean, you could actually graph it on Desmos if you'd like, but we know that this is a growth function because the base is greater than 1. So growth functions look like this. They go up, right? They go up, but because of the negative, it's going to grow down. And yeah, it shifts 1 to the right. So, I mean, you're not really going to be able to visually see that difference on a sketch. So it's still going down, but the k value is 9, so it shifts all the way 9 up. So what we have here is a graph that's way up here, let's say at 9. So here's your infinitely approaching asymptote that way, and then it curves, well, something like this, curves down that way. And this is saying that it'll never touch quadrant 3. Remember, quadrant 1, quadrant 2, quadrant 3, that is a true statement. So that covers all these true statements. There's only 2 of them. And of course, this is what you will see on your practice quiz. Not 2, none of these are correct, right? This one. Right here, they're asking what outputs, what y values, right? Outputs are y values. What outputs would correspond to the inputs, to the x values, using this function? So what you got to understand as you read this is that they're giving you these inputs, and these are numbers that you put in. Now, where do you put in these numbers? Inputs are your x values. So technically, they're giving you like a input-output table, and they're giving you the consecutive integer coordinates, -3, -2, -1, 0, 1, 2, 3, and they are asking you for the outputs of these corresponding integer inputs. So when you do figure out the outputs, the easiest thing to do is to plug in your easiest number, which would be the input 0. Okay, when you input 0 right here, 2 to the 0 is 1. Anything to the 0 power is 1. And then 1 times 8 is 8. So you get an 8 right here. And now you could plug in a 1 right there, a 2, a 3, a -1, and do all that math. Or the easier thing to do is to recognize that the base is 2, which means that this is a growth factor. That means that these outputs, because these are inputs in order, this output is going to grow by 2 to get to the next output. So 8 times 2 is 16, times 2 is 32, times 2 is 64. And if you're multiplying by 2 to get to the next outputs, going backwards, it would be dividing by 2, right? 64 divided by 2, 32 divided by 2, 16 divided by 2. Or you could think of it as multiplying by 1/2, right? Half of 64 is 32, times half is 16, times half is 8, times half is 4, times half is 2, times half is 1. So the correct answer here is the outputs 1, 2, 4, 8, 16. 1, 2, 4, 8, 16, 32, 64. This is my correct answer. Everything else is incorrect. Alrighty, let's move on. This one's a pretty straightforward, easy question. You just have to know what the different values mean, right? And of course, right here, I'm asking which of the following variables is the growth or the decay factor? Well, what determines if it's a growth function or a decay function? The b value. So if the b value is greater than 1, it's a growth function. If the b value is a fraction or decimal between 0 and 1, if it's less than 1, then it's going to be a decay function. So obviously b is the correct answer. All the other ones are incorrect. Now, of course, maybe on the test itself, I don't ask what is the growth or the decay factor. I could ask you which variable, A, B, H, or K, would determine whether it gets reflected. Oh, that would be the A value. If I say which variable would you use to state your horizontal asymptote, y equals what? Y equals K, right? Which would cause a shift left or right? Oh, that would be the H value. If I asked you what would cause a vertical stretch or compression, oh, that would be the A value. So it depends. You got to know what this entire form actually means with all the variables in it. So I hope this helps. Let's move on to the next question. State the y-intercept. So you could graph it on Desmos and see where this graph, this exponential growth function, because it's greater than 1, where it crosses the y-axis. Or you could remember Algebra 1 stuff. What did we learn in Algebra 1? To find the x-intercept, set y equal to 0 and solve. But they don't want the x-intercept, they want the y-intercept, which to find the y-intercept, you set the x equal to 0 and solve. Okay? So this is back in Algebra 1. I hope we still remember it. All you got to do is set the x equal to 0. There's x. Put a 0 right there. 2 to the 0 power is 1. 1 plus 3 is 4. So what does that really mean when you set x equal to 0? That means that your x value of your coordinate is 0. And when you plug in 0, the input 0 gives you the output of 4, which is your y value technically. So what is the y-intercept? It's the coordinate 0, 4. So here's your correct answer. Let's move on. I love these questions. They're pretty straightforward and easy. All you got to do is understand that this is a growth function, right? You don't even have to graph it on, I mean, you could graph it on Desmos, but you know that growth functions from left to right grow, yeah? But because it's negative, that means that it's going to get reflected over the x-axis, opening down, okay? And not only that, it doesn't have an h, so it doesn't shift left or right, but it does shift 2 up. So your new asymptote will be going through the y value of 2. So here's 1, 2. Here's my new asymptote, y equals 2. And we know that the actual graph, it's going to be this final yellow graph here. It's growing in a negative direction like that, okay? So what is the range? The range is always going to, I mean, you could think of it visually like this to determine your range, because obviously now you know that the range is y is less than that asymptote value 2. But here's a fact, algebraically, your range will always be y is less than your k value, or y is greater than your k value, okay? So it depends on, do you have a negative a which reflects it over the x-axis? So you do, so it's going down. So here it is, everything is below that y value of 2, so y is less than 2. I hope that helps. This is the only one that has y is less than 2. That's the only correct one. Everything else is incorrect. On this question, we have a exponential decay function, and they want us to find the outputs that correspond to the inputs. So we've already done one of these types of questions on this practice quiz. All we have to do is plug in these inputs into the x to get the outputs, the corresponding outputs. So it might be a great idea to make an XY table. As a matter of fact, I think there's an image here that you could click that'll show you the XY table, but it did get cut off, so I'm gonna redo it. And I'm plugging in the consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3. Let's go for the easiest one, which would be plugging in the input 0. The input 0, anything to the 0 power is 1, and 2 times 1 is 2. So now instead of plugging in a 1 and then a 2 and then a 3 and doing that math a bunch of times, all I have to do is understand that this is a decay function because the b value is less than 1. It's between 0 and 1, which means that the output 2 is going to decay by half. So what's half of 2? That's simply a 1. So instead of thinking half of 2, you could just think multiply 2 times 1/2. That'll give you 1. How about 1 times 1/2? That'll give you a 1/2. How about 1/2 times 1/2? That'll give you a 1/4. So if you're multiplying by half this way, then you're going to be dividing by half this way, which is really multiplying by 2, right? 1/4 times 2 is 2/4. 2/4 reduces down to 1/2. 1/2 times 2 is 2 over 2, which is 1. 1 times 2 is 2. 2 times 2 is 4. And then 8, and then 16. So the corresponding outputs for the inputs, -3, -2, -1, 0, 1, 2, 3, is 16, 8, 4, 2, 1, 1/2, 1/4. 16, 8, 4, 2, 1, 1/2, 1/4. There's your correct answer. Everything else is incorrect. Let's move on. This really is a great problem. It says, what is the a value and the b value of the exponential function that has no h or k's and passes through the points 0, -2, and 3, -54. Please type in answer with no spaces between terms and a comma separating the a and the b. Example, a equals this, comma, b equals that, no spaces between terms. Anyhow, this is what we need to do. Let's first start with what we know. We know that these two coordinates, 0, -2, and 3, -54, are points on this exponential function. Now, we don't even know if it's an exponential growth or a decay. So let's start by writing down the form of an exponential function. Y equals a times b to the power of x minus h plus k. Okay. And what else do they tell us? They tell us that it has no h or k values. Okay, so that makes it even easier. We could go back here and erase the h and erase the k. So that's what we have right now. And they're asking for the a and the b values. But what do they give us? See, in math, we always take what they give us to find out what we don't know. So they give us this point and they give us this point. Well, if we plug in 0 into x, then technically you know your a value is this y value. Think about that, right? If we say y equals, I don't know a, but if I plug in this x value of 0 up here into this x position, then b to the 0 power is 1, and 1 will be the answer a, okay? But instead of thinking of it logically, let's actually work through this, all right? Now, how do we work through this algebraically? We take what they give us, plug it in to find out what we don't know. So I am going to literally plug in the 0 into the x position, and I want to plug in this -2 into the y value position. So I'm going to have a -2 equals a, which I don't know, times b to the 0 power. So we do know that b to the 0 is 1. So I really have a times 1, which is just a, and you still have the equal sign, and you still have the -2. So we just found out that the a value is -2, okay? So let's go back to the original form that we know without an h and k, because that's what they told us. And we're going to plug in y equals, the a value is -2, okay? But we still don't know b, and it's still to the x power. So we've already used this point to find a. Now let's use this other point to find b, okay? So let's actually plug in the 3 right there and the -54 right there. So I'm going to have a -54 as my y value equals, we know that the a value is -2, so we're going to leave it -2, times b, which we don't know, but we do know that the x value is, in this case, 3, right? So we're going to put a 3 up here. So we have an equation now that we could solve for b. So we want b by itself. You have the multiplication of -2 and you have exponents. Which one do you get rid of first? You get rid of the multiplication first. So let's get rid of that multiplication by dividing by -2, dividing by -2. That will cancel out. you'll have a positive 27 equals b to the third. Now, how do we get rid of items, or how do we get rid of things? We do the inverse operation to get rid of it. So right here we had multiplication. Obviously we did the inverse of multiplication, which is division. What you do to one side, do to the other side. Right here we have the power of 3. What is the inverse operation of the power of 3? Well, the inverse operation of a power of 2 is a square root. So the inverse operation of a power of 3 is a third root. And what you do to one side, you must do to the other side, third root. So we will have b equals 3. So we have found our a and our b. We know the equation. The actual equation is y equals negative 2 with the base 3 to the power of x with no h or k. That's the equation. But how do they want us to type this in? They want us to type in the a value, comma, b value with no spaces between your terms. So go ahead and type in a equals negative 2, comma, b equals 3. That should give you full credit on this question. I think one more, it's worth explaining this. Why did I use the second point on this one? Well, if I would have found out my a value, and then over here, I plugged in my a value, and I use the same coordinates, it's not going to help us at all. All right, because when you plug in a 0 up here, it's going to cancel out. You're still going to get negative 2 equals negative 2. It doesn't give you the b value, right? When you plug in a 0, the b eliminates. So obviously, you have to use this point. Anyways, I don't want to confuse you any further. I hope this makes sense. Let's move on. What is the a value and the b value of the exponential function that has no h or k values and passes through the points 0, 5 and negative 2, 45? Well, again, you want to begin with what kind of function do you really want? You want an exponential function, which is y equals a times your base, that's your growth or decay factor, to the power of x minus h plus k. This is what we want. However, they tell us that it does not have any h or k values. So we could erase the h and the k. And they want us to find out the a and the b value. So what do we know? We know that a coordinate is 0, 5 of that graph, and another coordinate is negative 2, comma 45. Okay, so we're going to begin with the 0, 5. It's really easy to plug in 0 for x, and let's plug in 5 for y. So we have a y right here. We're going to put a 5 in its place, equals the a value. We don't know the a value, so I'm going to keep it a. We don't know the b value, so I'm going to keep it b. But I do know that x is 0, so I'm going to plug in a 0 up there. And now we're going to do the math. Anything to the 0 power eliminates and becomes 1. So you really have a times 1 equals 5. So that's really just a equals 5. So a equals 5. We found the a value. We still need the b value. Okay. So now that we know the a value, let's take this 5 and replace the a with it. We're going to have y equals 5 parenthesis b to the x power. Okay. And of course, we're going to be using the second coordinate. Negative 2 is the x value, so put that up there, negative 2. 45 is the y value, so put that right there in place of y. So we have the 45 in place of y equals the a value that we just found was 5 times the b value, which we don't know, that's what we're solving for, to the x power, and of course x is negative 2. So in this case, we need to solve for b. So what do we get rid of first, the multiplication of 5 or the exponent of negative 2? I will get rid of the multiplication of 5. How do you get rid of something? You do the inverse operation. The opposite inverse operation of multiplying is dividing by 5, and what you do to one side, do to the other side. You will have 9 equals b to the negative 2 power. So we need to understand how to get rid of that negative 2 power. Okay. One option is to make it a positive exponent by grabbing it, moving it to the other side of the fraction, not the other side of the equation, but the other side of the fraction. So you will have 9 equals 1 over b squared. And then you don't want your variable in the denominator, so you could multiply both sides by b squared. So this will cancel out, and you will have 9b squared equals 1. Okay, let me write that out. 9 times b squared is 9b squared equals 1. And then you could get rid of the 9 by dividing by 9, and you will have b squared equals 1 over 9. Now, to get rid of a square, you're going to do the inverse operation, which is a square root. So you're really going to get b equals plus or minus the square root of 1 over the square root of 9, which means that your answer is b equals plus or minus 1 over 3, because the square root of 1 is 1 and the square root of 9 is 3. So there's your b value. Now, we are going, because we're plugging in the b value as the base, we're going to just put positive 1/3. Okay, we're not going to put negative, because that's going to cause, it's going to not be an exponential growth function with a negative in there. So if you don't know what I'm talking about, the fact is, if you go to Desmos and you type in the graph y equals the a value is 5 times the base 1/3, just positive, to the x power, you're going to be able to see a nice exponential decay function that infinitely approaches the y value of 0 asymptote. Okay, if you type it in like that. So that takes care of the plus 1/3. But if you put a minus right here, it's going to disappear. The minus sign is going to cause it to mess up. And the reason for that is if you have an input of 1, and with a minus here, it'll be a negative answer. But if you put 2, then it changes to positive. And if you put 3, it'll be back to negative. So it gets all weird. So the only b value that we want to type in is 1/3. Okay, so they want us to type in our answer. It says please type in your answer with no spaces between your terms and a comma separating the a and the b. So the a is -2, comma b is 1/5. That's the example they give. We're going to say that our a value is 5. So you're going to put a equals 5, comma b equals 1/3, not plus or minus 1/3, just positive 1/3. And that's what the answer is right there. A equals 5, comma b equals 1/3. What is the exponential function that has no h or k values, that passes through 0, -2, and -1, -8? You could do all the algebra, or you could simply plug in your x and y values and see which one works for both of these coordinates. So pretty simple. If you plug in a 0 into x, will you get out a -2? 0 here, it's going to be a 1. 1 times a -2, yeah, that'll be a -2. Over here, same thing. Plug in a 0, that'll be a -2. Plug in a 0, that's not going to be a -2. So you know it's not this one for sure. Take that off. Once again, if you plug in 0 right there, 2 to the 0 is 1. 1 times half is 1/2. So this has the 0, 1/2 coordinate, not 0, -2. Whenever you see 0, any value, that's technically your a value when you don't have h or k values. Okay. So the a value has to be -2 in order for you to input 0 and get out -2. So it's one of these three, possibly, or maybe none of these. But let's do the other coordinate. Plug in a -1 for x, and you're supposed to get out a -8. So if I plug in a -1 right here, that's going to be 2 to the -1. That's really going to be a 1/2. Okay, 1/2 times -2 is -1, not -8. So it's definitely not that one right there. So as you can see, this does take some time plugging in your points. Another option is to just work through it the way we have on previous questions. Y equals a times b to the x. It says it has no h or k values, so I don't have to put x minus h, and I don't have to put a plus k. But we do know that the coordinate 0, -2 is going to go 0, -2, and that'll help us get some of these values that we're missing. So if we put a 0 up there, it's going to be b to the 0 times the a value, which we don't know, equals -2 for y. So we're plugging in 0 for x and -2 for y. And when you do that, you'll be able to eliminate the b, because b to the 0 is 1, and a times 1 is a. So you really have a equals -2. That really didn't help us because we already know that the a value is -2 there, the a value is -2 there, and the a value is -2 there. So we have one of those three options, but now it's time to find the b value. Okay, so let's go back to this form without h and k, and let's plug in the a value that we just found out, which was -2, and we also have the b to the power of x, and we will plug in the other coordinate that they give us. The other coordinate is -1 for x and -8 for y. So here's y. Let's put a -8 in place of this y, equaling -2 times the base, which we're about to find out what the base is, to the x power, which is -1, to the x power, which is -1. And let's do this math. We're going to get rid of the multiplication of -2 by dividing by -2, dividing by -2. We will get 4 equals b to the -1. Okay. And in a previous question, I actually moved this down, made it a fraction 1 over b to the 1, then multiplied both sides by b. Let me try to show you an alternative route. Maybe you prefer this route instead of the other route. Right here, what I want to do is think, how could I make this a +1 instead of a -1? Well, I could just take the entire right side and make it to the power of -1. Why is that? Because a power to a power, you multiply, right? Power to a power, you multiply. So whatever you do to an equation, as long as what you do to one side, you do to the other. So you're going to have 4 to the -1 over here, and there will be your answer, b to the +1, because -1 times -1 is +1, and you don't even need to write that +1. b equals 4 to the -1 power, which of course we know we need to grab it and move it to the other side. So you'll have an invisible, or a 1 up there, not invisible, it's an actual 1 up there, 4 to the 1 down here, which is really just b equals 1/4. So which one of these has the b value of 1/4? That's 1/2. That didn't work. 1/4 is right there, so this is the correct answer. There you go. So you could have gone and just tested plugging in x and y into all of them to see which one works, both of these points and both points in each equation. But this is the actual way to solve it, getting your actual a and b value.